Alright, let's look at the practice exam 3, problem number 8. Alright, so we have this integral and we want to use Green's theorem to turn it into a double integral, then evaluate it. Alright, so let's do that. Alright, so first we're going to identify P and Q. So it looks like the P is the guy in front of dx, right? So that's P. And the guy in front of dy is q. Alright, so Green's theorem says that if you have a p dx plus q dy, and you can write it as an integral, right, over the whatever the region, so I'm going to call it d or something like that, then you have a partial of q with respect to x minus partial of p with respect to y, right, and dA. Alright, so let's do that here. So we have, let's see, cosine of y. So actually, we have to take the partial q with respect to x. So you're going to get, let's see, 2x. You still have sine of y. Right, minus, then you have a partial of p with respect to y. So derivative of cosine of y would be a negative sine of y. So it's a double negative, so plus a sine of y. Right, so we got that. And then we want to find the bounds. Let's see, so you have, we have to probably draw a picture here. So you have xy plane. Alright, so here's x and here is y. Alright, so you are going from here, we are looking at the 0, 0 there. And then you go to 2, 0. So let's say this is 2. So we have a 2, 0 there. And then you go to 2, 3. So it's going to go up to 3. So I'll put the 3 there. Alright, so we know that this is going to be 2, 3 is right up here. Alright, and 0, 3 is right there. Alright, so the path is going to be, so you're going to go this way, and so going around this rectangle counterclockwise. Alright, so like that. Alright. So the region we're talking about is the inside region, so that's the region enclosed by the rectangle there. Alright, so you have a rectangular region, so you know that, let's see, x goes from 0 to 2, so we know that it goes from 0 to 2, and for y, it goes from 0 to 3, 0 to 3. Alright, so we have that. Right, and if you want, actually this looks kind of bad because you have a sine of y and sine of y. So we can pull it out and then we can probably rewrite it as, so sine of y, and you have a 1 sine of y. So we have 2x plus 1 then times sine of y, right? So that looks a little bit better. Alright, so part B, we need to evaluate the integral. And in this case, it's actually completely separable. So I'm going to go ahead and separate it. So let's do the ones with y. So it's going to be 0 to 3. Alright, only thing that has y is sine of y. Right, with respect to y. Multiply by integral from 0 to 2. Right, so you have the function of x is 2x plus 1, and then with respect to x. Right, so this is going to be antiderivative sine of y would be negative cosine of y, and then you're going from 0 to 3. Right, antiderivative of 2x is x squared, and the plus antiderivative 1 is x. And then you're going from 0 to 2, right? So this is going to be, right, so if you plug in 3, you have negative cosine of 3. All right, minus with the negative, so double negative, plug in 0. Cosine of 0 is 1, so it's going to be plus 1. So I'm going to actually plus 1 right in front. All right, so we have that. And then multiply by, so plug in 2, so 2 squared is 4, plus 2, so it's going to be 6 minus 0, so it's going to be 6. Can I put 6 in front here? All right, so that's the value of the integral we're interested in. All right, that's it. I hope that this was clear.